Let's keep going in section 2.7. We're talking about transformations. We already covered translations and stretches, and now we want to look at a reflection. What happens to the basic function y equals square root of x if we multiply it by -1 outside the radical? Well, probably we already know the answer. Multiplication by -1 gives us a reflection. We'll see that in just a moment. And when we do this multiplication outside the radical, outside the basic function, then that means we have a vertical transformation, a vertical reflection. And so we expect to get a vertical reflection for the function y equals negative square root of x. I went ahead and completed the table and the graph for the basic function y equals square root of x. And so now for the new function negative square root of x, we just need negative square root of 0, which is 0. Negative square root of 1 is -1. Negative square root of 4 is -2. Negative square root of 9 is -3. So we can go ahead and plot the points. 0, 0, 1, -1, 4, -2, 9, -3 is just off the graph, but that's okay. We can draw it anyway. And then we can draw a nice smooth curve through the points. So the graph in red is y equals the negative square root of x. The graph in blue is y equals root x. And the transformation in words is a vertical reflection. And it's important to say that we're reflecting over the x-axis. Okay, so let's move on. What do you suppose would happen now if we multiply by -1 inside the radical or inside the basic function? Well, remember, inside is a horizontal change, is a horizontal transformation. Multiplication by -1 is a reflection. If you imagine reflecting horizontally, then you're going over the y-axis. And we can even come out to the side here and sketch that out. You could make a table for the basic function and the new function. I didn't think that was necessary. So I'll just do it like this, just the rough sketch. Square root of x is the familiar basic function. And if we reflect it horizontally over the y-axis, then we wind up with something like that. That's y equals square root of -x. Okay, so let's summarize what we've learned about reflections. If we have y equals negative f of x, then that should be a vertical reflection. That should be reflected across the x-axis. And if you have a point xy on the original graph, then when you reflect over the x-axis, the x-coordinate stays the same and the y-coordinate changes sign from positive to negative or vice versa. So x negative y would be the new coordinates for the vertical reflection. Here in the next sentence, we're looking at f of -x, so that's an inside transformation. That means we're reflecting horizontally over the y-axis. And so the point at xy now would change x coordinates. X would become negative x, and the y coordinate would stay the same. Okay. Let's go on and let's look at example number 3. Let's try to put all this together. So in example 3, we have negative absolute value of x plus 2. And so the basic function is the absolute value function. And there are two transformations. We need to multiply by -1 outside the basic function. So that would be a vertical reflection, or a reflection over the x-axis. And then the second transformation is this +2 at the end. That's an do you remember that one? That would be a vertical shift up 2. And so then in part C, we can go ahead and sketch all this out. We're going to start with the basic function, the absolute value function. And then we're going to reflect it vertically. So this would be y equals negative absolute value of x. And then we're going to shift up 2. So we're going to move that vertex up 2. We're going to try to maintain the same shape, just shifted or translated over a little bit. And so that new graph in red is the function we're looking for. It's negative absolute value of x plus 2. Here's a nice point that we might make. Does it matter what order you do the transformations in? What if you shifted up and then reflected? Would that get you the same answer? Often I have students say you'll still get the same answer, but in this case that's not true. So let's just look at that briefly. If you shift up 2 units, then you get to here. Ooh, that's a little bit sloppy on my graph, but I won't worry about it. And then if you reflect that over the x-axis, then of course you wind up with something way down here. And this is not correct, right? You can see that's not the same as what we got when we did the problem just a moment ago. So sometimes the order of the transformations doesn't matter, but sometimes it does. And so we have to be real careful. What we want to do is we want to follow order of operations. When we look back at the function f of x, the absolute value gets multiplied by -1 first, and then we add 2 afterward. And so we need to preserve that order of operations when we're doing our transformations. Okay, let's go on to number 4. This is an example. This is a function that I gave you at the beginning of this section, at the beginning of the first video in this section. And so let's go ahead and do it. We have a basic function, y equals x squared. And then how many transformations do we have this time? You're multiplying by -3, but you know that's 2 different transformations, right? Multiplication by -1 is a vertical reflection. That's over the x-axis. And then multiplication by 3 is a vertical stretch. And so we have to be careful that we see two different transformations there, that the -3 has two parts that we need to address individually. So we have a vertical reflection, we have a vertical stretch, and we also have a vertical shift up 4. So let's go to it. We'll start with the basic function y equals x squared. And then we'll reflect over the x-axis. And that will get us y equals -x squared. And then we'll do a stretch, which is going to pull the points on the purple graph further away from the x-axis. So in effect, the graph is going to become skinnier. And then the last thing to do is to shift this up 4 units. So we can go 1, 2, 3, 4. We can plot the new vertex, and then we're going to try to preserve that that same shape from the green graph. Notice the red graph will cross the purple graph because the red graph is narrower, but the red graph never crosses, that never intersects the green graph. So try to preserve that fact in your drawing. We get g of x is equal to -3x squared plus 4. The green graph was -3x squared, and I think we're all done. Okay, let's summarize what we've learned about transformations, and then let's do one more problem that's similar but different to show what we know about transformations. So what does each of the following items do to a transformation? Multiplication, you'll say stretch or compression. And then multiplication by -1 is a reflection. Addition or subtraction is a shift, or we call it a translation. And then each of those can be done inside or outside the basic function. So inside will produce a horizontal change, and outside will produce a vertical change. So that's an important summary of what we've been practicing. Let's do one more problem and then we'll be done. Suppose the graph of f of x includes the point at 3, 4. Find the corresponding point on each of the following graphs. It might be nice if we just sketch the point at 3, 4 to help us to visualize what's going to happen. So there's the point at 3, 4. And if we have -f of x, then that's a vertical reflection. That's a reflection over the x-axis. And so the point at 3, 4 is going to come down here to 3, -4. And that will be our answer. In part B, f of -x is a horizontal reflection. It's a reflection over the y-axis. And so this time, the x-coordinate is going to change sign. We'll wind up at -3, +4. Part C, f of x plus 2. This is addition inside the basic function. Inside the basic function, plus 2 means to shift to the left 2 units. So here, let's change color pen just to keep track of this. 3, 4 is going to shift to the left 2 units, a distance of 2, and so now the new point is at 1, 4. If we have f of x and then a -2 outside the basic function, and that's a shift down 2 units. So then down 2 units would get us to the point at 3, 2. And finally, part E, 5 times f of x would be a vertical stretch by a factor of 5. So our point would shoot way up high. The x-coordinate would stay the same, would still be 3. The y-coordinate would be multiplied by 5. So 4 times 5 is 20. And so there is the new point. Okay, that's all for transformations. We have a couple more things to say in this section, and we'll get to that in the next video.